Hello, everybody. This is our study. It's on sleep deprivation and depression in Drosophila. And I'm Mia.
I'm Kaylee.
And Precious.
Here's our crew.
So to begin our study, we knew we wanted to just focus on depression. And so out of all the subtypes of depression, we decided to go with major depressive disorder because it has the most broad and general symptoms. And it's very prevalent in the US. It affects about 7.1% of all adults in this country. So that it's a very prevalent disorder. And so some of the signs and symptoms you can look for that come straight from the DSM-5 and they last for about 2 weeks before diagnosis include but aren't limited to depressed mood, anhedonia, slow thought, reduced physical movement, fatigue, loss of energy, feelings of worthlessness, excessive inappropriate guilt, diminished ability to think or concentrate, indecisiveness, and suicidal thoughts, thoughts of death. And I have two things I'd like to point out here. So anhedonia is going to be the subtype of behavior that we decided to focus on through our behavioral essays. And what that can include is going to be a disinterest in previously pleasurable activities. So in humans, that can manifest as maybe a disinterest in being social, hobbies, disinterest in sexual behavior, disinterest in eating as well. But also maybe an increase in interest in eating. So, and the second thing I'd like to point out is that you can experience a significant weight loss or weight gain with MDD. And that's just something to be aware of when doing research. And then something else is that studies have shown that about 60% of people will improve symptoms while taking SSRIs, selective serotonin reuptake inhibitors, and about 30% of that comes from actually the placebo effect, and 30% come from actually taking the medication itself.
So sleep deprivation, I think many people have experienced it before. So you might say, I thought sleep deprivation makes your depression worse. And that is true if it's chronic sleep deprivation, but surprisingly, acute can help. It's somewhat of a paradox. So it's been shown in previous studies that total sleep deprivation for a single night improves depressive symptoms in 40 to 60% of treatments. So it has a very early onset. In REM sleep, serotonergic neurons are silenced. And so that means that their serotonin activity is much decreased compared to wakefulness, which levels of serotonin are much higher. It has also been shown that extracellular serotonin is increased in total sleep deprivation compared to only REM sleep deprivation.
So for our knowledge gap, it is still poorly understood about the relationship between depressive behavior in connection to stressors in the external environment. And even previous studies suggest that environmental factors such as stress may even exacerbate depressive symptoms, making it worse. In terms of stress, it's often assumed that great amounts of stressors can promote a decrease in 5-HT neuron activity and can lead to extreme cases of activity decrease, leading to depression. However, we suspect that different intensities of stressors that better mimic human experience and demonstrate the efficacy of sleep deprivation in alleviating depressive symptoms. And we hypothesized that Drosophila exposed to different stressors, intensity levels will exhibit different rates of 5-HT neuron recovery when sleep deprived. And in addition, flies that experience stressors during their wake state will recover slower than flies that are not exposed to stressors. So for our process, the fly lines necessary were provided by the laboratory, and we utilized the GAL4 UAS system to generate 2 lines of flies with different levels of 5-HT neurons. The first line of flies, which was created by Mia in the lab were the 5-HT cross YFP fly lines. And the outcome of this cross involved yellow light activated halorhodopsin chloride channel, and manipulation via optogenetics will result in the deactivation of the 5-HT neurons. As a result, with low levels of serotonin, the progeny manifested a depressive state behavior. For our second line of flies, which were the 5-HT CS crimson, these lines were already available in the lab because they were created by Dr. Gobrogi. Since this cross involves neuron with red shifted channel rhodopsin, all 5-HT neurons of the progeny will be turned on when red light is shown, and upon activation, the fly lines will exhibit a hyperactive state-like behavior known as serotonin syndrome. And finally, for our control, we obtain wild-type flies.
Okay, so to begin our assay, we decided to make 3 chambers to focus on 3 different types of behavior. What we did was, for the first behavior we were looking for, it was going to be anhedonia of social behavior, which can be correlated with an increase in aggression. So our first chamber, seen in the picture labeled A, is going to be the fighting chamber. And what we did was, there was in the center a cup of fly food, just fly food, with a female thorax in the center of the food with the cup. And so that would kind of encourage the males to be more aggressive and show behavior, so that we had something to base our data off of. And then our second chamber was going to be the courtship chamber. And so in there, we placed a male adult and then a vegan female larvae. And so this was going to assay the interest in courting, interest in mating. And now, while mating wasn't going to occur because it is a larvae, males do express a lot of very typical behaviors when courting a female. So that was how we were going to gather data from there. And then our third and final chamber was the food chamber. And this was an assay on interest in eating, interest in food. And so about 5 to 6 flies were placed in there with a pedestal in the center and the food on top of the pedestal. And the reasoning behind that is to not only make the food a bit more difficult for the flies to access, because they'll either have to fly up into the cup or crawl up the slide to get to it, but it also kind of mimics a barrier that humans also may face in real life, where access to food may not be as easy for some than others. So that's why we have the pedestal. And in C and D, you can see that. In D, it's just a side view where you can see that the food is higher up and the flies kind of have a harder time getting to it.
So once we obtain our genetically manipulated flies and we were able to set up our chambers, we began our first behavioral assay, which was to record the baseline activity of both wild-type flies and the depressed flies. Our observations suggest that wild-type flies were active on an average rate, and meaning that their expected behavior were manifested. But if we compared wild-type and the depressed flies, our observation shows that the depressed flies had a lower motivational drive to engage in behavior activities such as courtship and aggression. But overall, nothing unusual was found, as the behavior they manifested were expected.
Yeah, and so just some numbers to help you gauge the comparison between the 2 types. If you look at the aggressive behavior between the wild type and the depressed, there's about a 60% decrease of behavior in the depressed flies, which was a bit unexpected because we were expecting them to be more aggressive toward one another, but they just showed a complete lack of interest in being social behavior at all, including aggression. So that does correlate along with MDD and anhedonia. Then there was also a 25% decrease in courting interest from the wild type to the depressed. And then the feeding interest did in fact increase by about 75%. But I'd just like to point out that while this doesn't correlate with anhedonia, it does correlate with behavior that is expressed in MDD. As I said before, interest in eating can either increase or decrease. So while here we were expecting it to decrease, it did take the route that is also definitely possible in MDD by being more interested in eating.
So unfortunately, our depressed flies died, and we had to come up with a new plan. So this is our second line. This is the CS crimson ones that display serotonin syndrome behaviors. And so we didn't have time to do the other behavioral assays, but we did focus on the interest in food assay. So we created 4 groups. So we had one group where we shined red light on them and then stressed them via electrical shock. And then we had another group that we didn't shine light on, and we also stressed them with electric shocks. And we had another group that we shone red light on, and we sleep deprived them via caffeine. And then we had the last group, which we didn't shine red light on, and we sleep deprived them with caffeine again. So we hypothesized that flies that will be exposed to red light will be quote unquote rescued from the electric shocks. And so what we mean by rescued is that because we shine red light on them, all their serotonergic neurons are turned on, meaning that they have very high levels of serotonin. So that would rescue them from the depressive behavior that we would assume would be from a stressor.
So starting with our shocked group, here you can see the apparatus. And so they were pretty much placed in a vial, and they were shocked with about 3 AA 1.5 volt batteries. And then they were placed in their 2 respective chambers of red light and non-red light. And so what we saw was that these flies, so what we saw was that for these flies, there wasn't that much of a difference between the 2 that were shown with the red light and the ones that weren't. So it was only by a margin of about 1. So 1 difference in display of interest between the ones that were shown with the red light and their serotonin neurons were active. So what this can tell us is that while there isn't that much of a great difference between here with these stressed flies, now just a reminder that these flies were not sleep deprived, that this will then bolster our other information that we have on how sleep deprivation coupled with the activation of these serotonin crossed channel-rhodopsin neurons, it kind of shows that while the stress isn't a big factor, it bolsters the effects that you're about to see in the next slide.
So from the behavioral assay, we noticed that flies that had red light shown on them showed significantly more interest in food than the ones that didn't have light shown on them. So this might be contradictory to the data we found before, where the depressed flies showed more interest than the wild type. And so we hypothesized that this was because the YFP line, the depressed fly line, was showing symptoms of major depressive disorder, not necessarily anhedonia when it came to food interest. And we think that these serotonin syndrome flies, because they were shown red light, they displayed more interest in food, meaning that they were, I guess, rescued from depressive behavior if they had any. And so this indicates that the activation of the serotonergic neurons could be coupled with sleep deprivation may in fact promote interest in activities, like I was saying before.
In conclusion, due to many unpredictable changes that we faced in our lab, we could not conclude anything about the direct relationship between sleep deprivation as a treatment for major depressive disorders in the YFP tag. fly line.
So we did see a correlation between sleep deprivation and increased feeding in the CS crimson line, like I was saying before. And so we found that there was 143% more interest in feeding than those that had the lights shown off, right?
Yes.
So improvements for the future. So unfortunately, we did not get to image the CS crimson fly brains because M Venus and YFP emit light at 514 nanometers to 527 nanometers. And that's something that it's very difficult to see if you don't have a confocal microscope. So we did image M Cherry. So M Cherry are these M Cherry tag seizure brains, and so they visualize much better than M Venus. You can see here there's a lot of great expression, and even here in the 40x, you can see that you can see individual cells even. So an improvement would be using a confocal microscope to visualize the CS crimson YP tagged brains.
And so continuing on our improvements, as you may notice now, we use caffeine to sleep deprive these flies, but a lot of other studies have gone about different routes in order to sleep deprive their flies or rats. In this study here, they actually put them on a little circular disc, and so the disc would rotate anytime that any criteria, and they probably chose specific criteria that they were looking for that would be considered entering QS. And so every time that they did that, the disc would rotate and keep them awake. Other routes we could have taken, maybe shaking them, and sort of like the same kind of idea. We could shine light that would actually disrupt their circadian rhythm, or even use very loud sounds to keep them awake. But we did use caffeine, and that just had to do with more limitations of the lab and time limits and money sort of deal. But caffeine, it did work clearly, but it does have, because you need to be very specific and accurate with your quantitative measurements of caffeine that you're administering, and you have to make sure that they ingest all of it. It's kind of a difficult route to take, but I think that the most important thing that we decided on, if we were to ever do this again, would be to have another line of flies for backup, because we were about 4 weeks out, and then they died. So we had to come up with a new plan, which, not necessarily a bad thing, because we did get some great data on the effects of sleep deprivation on interest in eating in those serotonin syndrome flies. But just in case, it's good to have a backup, I think.
So connecting it to a broader impact, why should we care about sleep deprivation in general? It turns out that previous studies have demonstrated benefits of sleep deprivation. For example, in this study, coupling it with antidepressant induced amelioration of mood of depressed patients. And in this pilot study, sleep deprivation actually mirrored the effects of antidepressant itself.
So a very hot topic is ketamine being used as a antidepressant, well, coupled with an antidepressant, but it is very invasive because it has to be taken via IV because of its very high abuse potential. And so this may not be covered by insurance companies because they may only cover SSRIs. So sleep deprivation is very non-invasive. I mean, it's free and it has a very early onset like ketamine. And SSRIs have a very slow onset. It might take 1 or 2 weeks for it to start working. And so this is extremely important when it comes to patients with suicidal ideation, because they may or may not have a plan, and it's very important to get them feeling better as soon as possible. So thank you so much for listening to our project. We really appreciate it.
Yeah, thank you so much. Please reach out to us if you have any more questions.